Hello everybody, welcome to MATL 3101 Metals Lab. This is Lab 1, thermocouples. So we also would like to cover some safety procedures today. So we're going to do a little bit of both. First of all, with regard to safety, obviously we're in the middle of a pandemic, so the primary safety procedure we're going to wear is a mask. Now, I am not wearing a mask right now because the building is essentially empty, but if it were not empty, I would be wearing a mask, and you need to wear a mask as well. You also need to wear safety glasses throughout the course in all the labs, and you need to make sure that you socially distance, wash hands thoroughly, avoid touching your eyes and face, and all other pretty well-known virus preventative measures. Other safety issues, we're going to be working with hot items, we're going to be working with pinch points and tensile testing, which can, in rare circumstances, result in the potential for particles flying. So we're going to be very careful with all these things and take precautions. And I want you to make sure that you read the safety procedure that Dr. Liu has provided. You need to sign that document and return it to him, please, as soon as possible, no later than the second lab. I hope I haven't forgotten anything. Safety is the primary focus we want to pay attention to, so please do that. Now, with regard to thermocouples, hopefully you've read the background material and you know that a thermocouple is an electrical junction between two dissimilar metals. In this case, it's a K-type thermocouple. There are many types of thermocouples, but this is a K-type that we're working with. And the two dissimilar metals are chromel and alumel. Now, when in a thermocouple junction, two dissimilar metals making contact can produce or will produce a temperature-dependent voltage, which can be interpreted by an electrical meter, such as this one. So the thermocouple plugs in, you can set the meter for the type of thermocouple and the range scale that you want to use, Fahrenheit, Celsius, so forth, and you can use it to measure temperature live. Now there are other devices which can record temperature changes using a thermocouple, and we'll probably work with one of those in a later lab. This is not a recorder, this is just a reader, okay? But it works for our purposes today. So, again, a thermocouple, this is one here. It's two dissimilar wires, which are both contained in this fiberglass sheath. They are yellow and red, and that's a color code to let you know what the metal is. We have spot welded a junction on the end of one of the connections, and we have on the other end made a connection into a thermocouple plug connector, which can be plugged into the meter. So this is what the finished product will look like, and I'll show you how to make one. So the first step to making a thermocouple is to take a segment of wire. It doesn't have to be this long. This one just happens to be about 2 feet, but you want to make it about 12 to 15 inches. I hope you can see this on the video, but if you carefully remove the fiberglass sheathing on the outside of the wire, then you'll see that there are actually two smaller wires inside, and they're color-coded, in this case, yellow and red. Now that's a sort of an international standard to identify this as K-type thermocouple wire. And by the way, different types of thermocouples have different temperature ranges for which they are suitable. K-type is very useful for a wide range of temperatures, and it's pretty much pretty common, so we're going to use that. So I have removed the outer sheathing, which is made of fiberglass, and have exposed the two internal wires, chromel and alumel. And you want to do this pretty much on both ends of the wire. I haven't done it on this end yet, but I have on this one. And on one end, you want to carefully remove the yellow and red insulation and get ready to form a thermocouple junction. And I'll show you how to do that in just a minute. On the other end, you want to strip the wire just like this and leave them separated, because we're going to attach them to a K-type thermocouple plug similar to this one. And the wires, the yellow and the red, go to the positive and negative terminals on the plug. Now, I may not have said that in the right order. Chromel is yellow, and yellow goes to positive. So that's the way I remember it. I'm positive that Chromel is yellow. So that's the way I remember it. But these are all published in the literature, so you don't have to remember that necessarily. But it does matter which way they're connected. Again, this is on the thermocouple connector side. On the other end of the wire, we're going to make a thermocouple junction, which will be our temperature reading device. So the next step in making a thermocouple, after you, and by the way, I'm using a thicker gauge wire than the one I just showed you, which is okay. We have different gauges, but I figured that this this gauge of wire would show up on the camera better, perhaps. So hopefully that's the case. So the first thing you want to do is take the pliers and make a junction. So you literally take the needle nose pliers and twist the exposed ends of the wire together and make a spiral junction like this. Maybe do about 3 or 4 turns. Okay, and try to keep the wires separated in the upstream part of the junction, if you will. So you want to have them separated here, and you want a nice junction at the end. Now, that looks pretty good. Let me get it a little tighter. In fact, I think I'll hold the open part with one set of pliers and make a little tighter twist with another set. I'm not sure. You just have to do what works best for you, and it may take some practice. So once you have a spiral, then you want to cut most of it off and leave a pretty good sharp tip, tight end, if you will. And you might want to compress these a little bit, and so you end up with something like this. Okay. So the next step in making a thermocouple, after you twisted the ends together, is to make a thermocouple junction with a thermocouple welder. So you take, this is the thermocouple welder, the Miyachi Unitech TC welder. You take the probe out of the machine, and this probe is a little worn, so you have to work with it, but there's a knob on the right hand side. Pull it down, which expands the probe and then allows you to insert your twisted wire into the probe and then close it back up, leaving approximately 1/8 of an inch of exposed wire sticking out of the probe. And then close it up as much as you can. And probably the wire that we'll be using is a finer gauge, a larger gauge than this. So it will probably close better and work better on the gauge of wire we'll be using. But this gauge probably shows up better on the video. So again, you're inserting the twisted portion of your wire into the probe, leaving approximately 1/8 of an inch exposed, sticking out of the end of the probe. Close it back up. Then come over to the thermocouple welder, turn it on, adjust the wire gauge for the type of wire you're using, and of course, before we turn it on, we have to make sure it's plugged in, as in most electrical devices. So, plug it in. Now let's turn it on. And there we go. So, we have a power indicator and we have a weld ready indicator. So it's ready to go. Except for one thing, which is that we have to turn on the gas. The bottle is located behind this antique refrigerator. It is nitrogen, and the gauge is probably, the regulator is probably set for the correct pressure, but let's check that. Turn on the gas carefully, watch the gauge, and also watch the airflow meter located behind this saw, and see that it's about, the ball indicates that the airflow is about mid-range, which is about right. So we've got airflow in the right range, we've got pressure, and we're ready to go. Okay. So now we can insert the thermocouple probe into the thermocouple welder and listen. And there is a welding operation. Hopefully you can see that little ball at the end of the wire. I hope you can see that, but there is one there, and that is our thermocouple junction, if you will. Okay? I've got to tell you that I'm very surprised that that happened the first time. Usually it will take 3, 4, 10 times, but that was nice for purposes of this video that it actually worked the first time, and you got to see it live. Here's one that I already had made up. Hopefully you can see it as well. There should be a little ball at the end of the junction, which is your thermocouple joint. So now we have a complete thermocouple wire, which you can buy, of course, already made up. It's much more expensive and not as much fun to make, but we have a junction on one end, we have the connector on the other, and we have our thermocouple reader. Now, the thermocouple reader, this is the power button, and when you press it, you can see a very simple display where the type of thermocouple is shown K, and the scale that we're interested in, Fahrenheit. You can adjust these. This is the scale for Celsius, Fahrenheit, and Kelvin, and you can use the setup the setup button to change the type of thermocouple. But it's set properly now, and all we have to do is plug in the thermocouple, and notice that there is a difference in the connection there, and the thermocouple connector, the K-type, will only go one way. There's a wide one and a narrow one. It goes this way, and once we plug it in, we can read the temperature in this very cold room, which is about 63.1 degrees. You can test your thermocouple by placing it between your fingers, and notice that the temperature goes up almost immediately to approximately 90 or so degrees. It's not going to be as warm as a temperature measurement device that we've, or as accurate. Well, between your fingers is not as accurate as some of the temperature reading devices we've all become familiar with over the last few weeks. But you can see that it's recording pretty accurately, and this is just a check to make sure that your thermocouple is working. Let go of it again, and the temperature responds or returns to the room temperature. Okay. So, for purposes of our lab today, once you've made your thermocouple and determined that it works properly, what we want to do is use the thermocouple to make some temperature measurements. Now, some of the best things to measure for purposes of illustrating accuracy, repeatability of a thermocouple, there are two things. Boiling water, which is known to be constantly, isothermally, 100 degrees Celsius or 212 Fahrenheit. And the other thing that we can measure that we know the temperature remains constant is an ice bath, an equilibrium mixture of ice and water in steady state, which will be 0 degrees Celsius or 32.15 degrees Fahrenheit. So what we want you to do in this laboratory is, once you make your thermocouple, take multiple readings, I would say 5 to 7 readings of boiling water, using, very carefully by the way, using a hot plate with a Pyrex beaker of boiling water. And I do not have one, but at this point I think it's sufficient to just simply describe what I'm talking about. So you want to get a hot plate, you want to bring some water to a boil, and we'd like for you to make 5 to 7 temperature measurements of the boiling water, each of which should be very close to 100 Celsius or 212 Fahrenheit. The reason we want you to make multiple measurements is because for purposes of your lab report, you need to take these record these measurements and perform averages and statistical analysis on the measurements to demonstrate accuracy, repeatability. So please perform average of those numbers and standard deviation of those measurements as well. Do the same, please, for the ice bath. Record those measurements, 5 to 7 at least, and perform the average, standard deviation, and report all those values. The next thing we're going to do is I'm going to show you how to make your thermocouple, how to attach it to a substrate, a metal substrate, and for purposes of monitoring the temperature, maybe you desire for the temperature of your device that you want to monitor to remain constant. Perhaps you want to measure temperature over time. But the way to do that is to attach the thermocouple to the substrate, and then you can use that to make a direct measurement of the item of interest. So for that, we're going to use the Unitech spot welder, if you will. And so the first thing we need to do is set your thermocouple down. We've got to create the electrical circuit needed for making a welded joint here. So I'm going to take this electrode clamp, attach it to this copper block to make a good connection. Maybe twist it back and forth to make a good connection. Place your substrate, which should be clean. Maybe with a wire brush or a grinder, remove oxides and oils and so forth to make a clean surface, and place it on your substrate so that it's electrically connected, and you can complete the circuit. Next, take the electrode in your right hand, and you really kind of need 3 hands for this, but we'll just it's a little bit difficult to do with 2, but obviously it can be done. So turn the power on. And once again, make sure it's plugged in. Okay, so it's plugged in. Turn the power on. You should see the weld energy come up to some value, and you can adjust it as needed, but start low. So we've got our substrate on the conductive block, and we've connected the circuit, and we're pretty much ready to go. I just need the thermocouple junction that we just made. Place the thermocouple junction on the substrate, hold it down with the electrode. Okay, and then using the firing switch, will make our weld. Okay, not enough energy, probably. Let's check that. Yep, we have no connection. So I'm going to replace the electrode holding the thermocouple in place. I'm going to turn the power up a little bit. And try to create a spot weld. Again, no result. Turn the power up a little more. At that time, I saw a spark, but we still don't have a connection. A little bit more power. There we go. Turn the power off. Our thermocouple is connected, excuse me, welded to the substrate. We can plug it in and monitor the temperature of the substrate, whatever process we want to put it through. Okay? And later on, this will probably have more meaning because this is actually a Sharpie impact sample. And later on in this lab, we'll, or in 3101, we'll use welded thermocouples to monitor the temperature of a Sharpie test sample as we run our lab. Okay, thank you very much. If you have any questions, again, I'm Mitch Ingram. My email is wmi0001@auburn.edu, and I'm available to help you throughout this course, and we'll also probably talk by phone or Zoom, and it's very likely we'll schedule regular Zoom meetings every week for anyone to ask questions as they come up. This is a different way of teaching the lab than we've done before, but we're making history here, so we'll do it. We'll do it well, and looking forward to it. Thank you.